So today's video is going to be a little bit different. In today's video, we're going to talk about some of the logistics behind the project. So first, we're going to take apart the accelerometer and talk about some of the key components in it, including the Arduino Nano. And then we're going to explain some of the physics behind how the Arduino Nano obtains its data. And lastly, we're going to talk about how we use the accelerometer as a whole to obtain our data and put it into Excel to then create the graphs that you guys use to solve our puzzles.
All right, so here we have our accelerometer as a whole. If I take the top off, we can see the inside of it. And this is the Arduino Nano 33BLE, which is a small microprocessor that we are using for this project. We decided to use this microprocessor because it has a built-in accelerometer. And over here, this is our other Bluetooth chip that we are using instead of the Arduino Nano 33BLE. So the Arduino Nano 33BLE has a built-in Bluetooth, but it's not fast enough for the purposes that we're trying to use it for. So instead, we're just connecting it to another Bluetooth chip that has the capabilities that we need in order to process this data. So you can see there's also a bunch of different wires in here, and you probably don't know where they're going or what they're doing. So we're going to do a short pinout to show you what each of these pins on the Arduino Nano does and why each wire is connected everywhere. Here we have our Arduino Nano 33BLE chip, and over here we have our Bluetooth HC05 chip. To start off, this red wire down here is connecting the positive terminal of the battery to the Arduino Nano at the V-in pin to provide power to the Arduino Nano 33BLE. Then also we can see up here, this black wire is connecting the negative terminal to the Arduino Nano 33BLE at the ground pin, which basically completes the circuit, allowing the electricity to flow into the Arduino Nano and then flow back out to the battery and have a complete circuit. Next, over here, we can see our TX and RX pins on both the Arduino Nano and the Bluetooth HC05 chip. On here, the TX or transfer pin is connected to the RX or receiving pin on the Bluetooth, meaning that all of the data that the Arduino Nano sends the information from this terminal here to the receiving terminal on the Bluetooth. And then vice versa. We also have a transfer pin over here on the Bluetooth HC05 that is connected to the receiving terminal on the Arduino Nano 33BLE. Next, we can also see up here at the 3-volt pin, this is sending the electricity that the Arduino Nano gets from the battery to the Bluetooth chip so that it can then be powered and actually be able to function. And then we can also see that there is another ground chip over here on the Bluetooth that is then connected to the ground chip on the Arduino Nano down here so that we can then complete the circuit to the Bluetooth pin. Now, you can also see that there are plenty of other pins on here that are not being used currently. This is just because we simply don't need them for what we're trying to do here. If you wanted to, you could have an external accelerometer that you could connect with these analog pins over here, but we don't need it because we've already got our accelerometer in the chip. All right, so when the Bluetooth HC05 receives data from the Arduino Nano, it can then use a protocol to transfer that data to an app on the phone. So we use the Serial Bluetooth app that helps to receive the data from the Bluetooth chip and then create a visual of each of the data points. In the first video, we showed you how the data points work with the accelerometer moving around and the data points showing up on the phone. We can see here on the info in the Serial Bluetooth app that the devices implemented are compatible with HC05, which is what we use. And now to go over the coding behind the Arduino Nano. So first of all, the Arduino Nano is actually really easy to program because all of these programs here, all these lines that you can see here are very easy to find on the web. And then also this platform that we're using here is called the Arduino IDE program, which you can find on the Arduino website and helps you write your program that you can then upload to the Nano really easily. So now we'll go over some of the key lines in here that will help the Arduino Nano to run smoothly. This first line up here with the include is the Arduino library, the accelerometer library, that has a lot of key functions in it that help the accelerometer part do its job. And then next on this line down here with this float, it's defining the x, y, and z variables as they will represent our acceleration in each of these directions: x direction, y direction, and z direction. Next here we have this short setup program here that will connect our Arduino with the Bluetooth chips that we can send the data that the Arduino captures to the Bluetooth chip. Now, this line here is actually very important to start with the serial 1. The serial 1 defines the transfer of data from the Arduino Nano to the Bluetooth chip as using the TX and RX pins that we showed in our previous section with the pinout. Instead of, if this was just serial instead of serial 1, then the Arduino would think that it needs a USB cord to be connected from it to the Bluetooth chip in order to send the data, which we didn't use a Bluetooth or a USB cord because it's too chunky. So this final part down here is a loop, so it means that the Arduino Nano will try to go over everything in here as fast as it possibly can. So it basically calls in two functions from this library that we showed up here. One, this one here, is if the accelerometer is available, then use it. And the other one is to grab the accelerations from the x, y, and z accelerations. So once we have our accelerations down here, the accelerometer will print or send the data points through the serial 1 connection to the Bluetooth chip, and then repeat the loop over and over again. And once the program is written and doesn't have any bugs into it, all it really takes is just one USB cord connection to the Arduino Nano, a click of a button, and some time, and then your Arduino Nano is completely programmed and ready to go to be used for this accelerometer project.
So as you know, the Arduino Nano 33BLE has a built-in accelerometer. This and other accelerometers use a specific method to determine the acceleration. In our accelerometer, it uses a device similar to this one here, in which there is a mass attached by a spring on one side of an enclosed box. On the other side, there are two rods that help measure the capacitance, or the amount of positive and negative charges between the two. When the rods are further apart, as shown by the device at rest, there is less capacitance, meaning not as much charge on either rod. Say the device, however, is accelerating to the right. When this happens, the inertia of the mass, or its resistance to movement, causes it to stay in its original place, stretching the spring and moving the rods closer together. When the rods move closer together, the capacitance increases, sending a signal to the microprocessor that an acceleration has occurred. This can also happen on the flip side, where it accelerates in the left direction, and the rods get further apart, lowering the capacitance from the resting point. Also, keep in mind that this is an example of only one of the three axes, so in the actual accelerometer, there are sensors or rods that will detect the acceleration in all three planes, x, y, and z. Unlike the device accelerating in one direction, the force of gravity is also constantly pushing down on the mass, meaning that in the resting position, in the z or up axis, the mass will not be in its resting position inside the box, and the rods will be closer together than in any of the other directions, resulting in a constant gravitational acceleration on the device. Another way we can look at this is using Hooke's law, that F equals negative kx, or the negative spring force constant times the distance of the spring. We can equate this to Newton's second law, where F equals ma. When moving the variables around, we end up with negative kx over m equals a. Since k is already a constant and the mass in the device is already known, all it needs is to find the distance that the spring stretches or recoils to find the acceleration. After the accelerometer acquires its data, the Arduino Nano takes it and sends it to the Bluetooth device, which then uses a protocol to transmit the data to the serial Bluetooth app on the phone. We can then input this data into Excel to create our graphs that you guys use to solve those puzzles.
Okay, so now we have our data set here that we want to input into our Excel file. So what we're going to do is we're going to click on it, and you can see that each of these data points over here is separated by a comma, which is good, but these ones over here are separated by a space, which is not good. So what we're going to do is we're going to go up to Edit, Replace, and we're going to replace all of the spaces with commas. replace all. And now you can see all of these data points are separated by commas, which Excel will like when we try to input it. So now we can save this, and we can create a new Excel file that we can import our data into. So how we import the data is we go to File, Open, this PC, the specific file that the data is in, and then instead of all Excel files, we'll go to All Files, and then open our data set. Now here we'll ask whether we want delimited or fixed width. We want delimited, and we want to set this to comma because now all those commas that we made before now helps us separate each of our data points. And click Next. Text instead of general or date because general and date cut off some data points, which is not good. And now we have our data into our Excel file. The only problem is that Excel doesn't think of these values over here as time values. Instead, it thinks of it as just regular old numbers in a cell. So what we want Excel to do is we want it to think of these values as time values. So what we'll do is equals time value, parentheses, then the specific cell, which is A1, and enter. So this is the percentage of the way through the day that this time period is at. So at 9:03, it's approximately 88% of the way through the day. Now this is cool, but it's not really very helpful to us in this project. So instead what we're going to do is convert this percentage into seconds. So we're going to do E1 equals E1, which is that cell, times 86,400, which is the amount of seconds in a day. And now we've got the amount of seconds in the day that 9:03 shows up at. Now, this is getting on the right track as we're in seconds now, but we don't want to start our graph at 75,000 seconds. We want to start off our graph at 0 seconds. So what we're going to do is we're going to go to this file here and do equals F1, because that's that cell, minus itself, but with a little bit of a twist here. So we click enter. Now this data point is starting off at 0. But what you're going to see in a second is that not all of these data points here will be 0. So when I copy and paste all of these, so copy, go all the way down, bottom here, and paste. Now you can see that all of the data values are here for each one. And these ones here are not 0. They're going up by a certain amount, certain small fraction of time. So now what we'll do is we'll take each of our data points over here, copy and paste them. And now what we can do is we can select each one of these here. And we can go to Insert, Chart, Line Graph. And here we go. Now we've got our graph here that has all of these time values on the x-axis, and then all of these x, y, and z values on the y-axis over here. Now, the difference between this graph here and a graph that you might see in the video, for example, this is the ramen data. So in that first video with the car map, the graph that you would see in that video would be much smoother because you can see in here, there's all these little like up and down vibrations here. The graph is very noisy, as we would call it. So what we do in, for example, in the graph for the ramen graph is we'll take the running average of each of these lines, which will basically make the line smoother so that all of these up and down vibrations they're not there anymore. So it's easier to read when each of the lines is just straight.
So thank you guys for watching this video. We hope that you found the information helpful in showing how we create these puzzles for you guys to solve and to use if you guys wanted to do this on your own. In our next video, we'll be explaining the solution to the exercises puzzle and providing a new puzzle for you guys to solve next time.
Thanks.
Thank you.
See you in the next one.